All right, so let's kind of continue with what we were doing last class involving sequences. More fun with sequences. All right, so we'll kind of review. Let's see, can we write an equation that fits this sequence? So kind of try that on your own. Okay, so we're adding 4 between each term. Okay, so that gives us the d value of 4. Work backwards to find what the 0th term would be. In this case, 11 minus 4 gives us the c value of 7. Okay, so now find what is t of, how about just, what's the 30th term? Find t of 30. Good. So we wouldn't say t of n, we'd say t of 30. So, but we plug in 30 for n, so we get 120 plus 7. So t of 30 equals 127. Very good. Okay. So now the other type of question we could get asked is something that looks like this. Is 215 a part of the sequence? Okay, so it's a little bit different here where we're asked to find t of 30, we're plugging in 30. But it's different now when it says, is this a part? Essentially, we're asking, can we plug something in for n that's going to give us an answer of 215? So we would try and solve, subtract 7. We get 208 equals 4n. Divide both sides by 4. And we get n equals 52. So determining if it's part of a sequence, this has to be a whole number. Okay, and that's kind of the main thing to take away. Okay, this has to be a whole number. It couldn't be like 52 and a half, okay, because that would basically mean that it's the 52 and a half term in a sequence, which doesn't make any sense. You don't have a half of a term in a sequence. You just have the first term, the second term, the third term, so on and so forth. Okay, so try this on your own. You get -9, -6, -3, 0. Find t of 75, or write the equation, find t of 75, and then determine if 300 is a part of the sequence. As our equation, Gavin, what'd you get for t of 75? You got what? I think you got 225? Yeah, you just forgot to subtract the 12. So subtract the 12 and you get 213. Hey, Leah, is 300 a part of the sequence? I got yes. I could be wrong, but I don't think I am. Okay, so we should have plugged in 300 for t of n. Add 12 to the other side. So we get 312 equals 3n. Divide both sides by 3. We should get 104. So a couple different places we could have slipped up. That's okay. Okay, do the same thing for this next one. Okay, write an equation. Find t of, we'll just go 60. And determine if, let's say, -208. I don't know, just pick a random number. Seeing some good stuff. Okay, getting an equation right is obviously a big part of this. So you get -5n plus 20, subtracting 5 each time. Term before 15 would have been 20. Okay, then we plug in 60, so we get -300 plus 20 gives us -280 for that 60th term. And then plugging in -208 for t of n, seeing if it gives us a whole number. It does not. Okay. Could also, kind of use common sense a little bit. Each of these numbers is, we're increasing by 5. So it's, 5, 10, 15, 20, 25, 30, so on and so forth. Okay, you can kind of understand that -208 isn't going to be a part of that. Same thing if it was, 2, 4, 6, 8, 10, where it's increasing by 2 and they're all even numbers, and they asked you if an odd number fits. Okay, you can kind of recognize that as well. All right. The other thing I want to take a look at would be a word problem of sorts. Let's say Anderson has $800 and saves $50 every month. Let's write out much I'd have for the first 6 months and then determine how much I'd have after, let's just say 30 months. All right, so a couple different ways we can attack this. Okay, but let's just kind of treat it as we would, dealing with sequences. Okay, if I wanted to kind of just make a table, okay, the big difference between, okay, just given a sequence and given a word problem is usually they give you the zero term, right? So how much money do I have after month 0? Well, that's whatever I start with. And in this case, it would be 800. Okay, because I haven't saved any money yet. Okay. So now after the first month, I've saved $50. So now I have $850. Next month I have $900, $950, $1,000, $1,050, and then $1,100. All right. So now if we want to write an equation, okay, and we want to figure out how much I'd have after 30 months, okay, we're still going to use T of N. Okay. How much are we increasing by each month? 50. All right, increasing by $50. And then again, we want to use our starting values. So they actually give us the 0th term. Okay, in this case is 800. So we wouldn't want to go backwards to month -1. Okay, we want to start with month 0. So in this case, we're starting with $800 and then we're adding 50 on top for each month. So to find out how much we'd have in 30 months, we're just plugging in 30 for N. And numbers are a little bit bigger, but that's okay. $50 times 30 is 1,500. 1,500 plus 800 gives us 2,300. All right, we'll try another one. Okay. So I want to pay for her daughter's college in 16 years, put $1,000 into an account, add $300 every month. Okay. How much am I going to have in 16 years for her college? Okay. So again, adding 300 every month. So it helps to know that 16 years is 192 months. Most part pretty good. A couple of small mathematical errors. Okay. Well, should end up with $58,600. Hopefully is enough to get her through college. But when she gets that golf scholarship, all that money's going back to daddy. So buy myself a nice little new car or something. I don't know. So no pressure on her or anything. Just better not let me down. Just kidding. I've tried to play golf with her before. She's only 2.